Hi everyone. So far we've been talking about how the nephron functions, how it filters things in your bloodstream and puts them into the nephron, how it finds out, hey, there's some things in the nephron that we want to keep and puts it back into the bloodstream through reabsorption, and even sneaks some things through the nephron through excretion that are seen as waste products, but we haven't really talked about what that results in: urine. The urine is a good indicator of a patient's health, and we will be looking more at urine later on in the unit when we talk about urinalysis. But one thing that urine shows us each and every day is hydration. So I wanted to kind of bridge the gap between what the nephrons are doing and how that results in something that we see all the time: how hydrated you are through your urine, and why your kidneys are able to show you exactly how hydrated you are and what exactly is happening. So we already know that the functions of the kidney is to form urine, and by doing so, they are actually allowing themselves to balance the acids and bases inside your bloodstream because it's getting rid of some of the more acidic things, as well as regulate osmolality, the ions that are inside your bloodstream, and even regulate your blood pressure. And it does all three of these things by maintaining the amount of water that is in your bloodstream. The more water that we have in our blood plasma, aka how much more the kidneys and nephron are doing their job by retaining the water, that means that there will be less water in the urine and there will be a higher blood pressure because of it. And because there is a less water in the urine and more in the bloodstream, that would be leading to a lower concentration of salts in the blood, kind of like making a jug of Kool-Aid. If you have a bunch of water in that jug, but not a lot of the Kool-Aid itself, is seen as a less potent, more weak solution of Kool-Aid. We're talking about our plasma being the solution, and the lower concentration of salts in the blood would make it a very, very weak blood. The opposite can be true. You could have a lot of water in the urine instead, and therefore more water or less water in the blood plasma. That would lead to a lower blood pressure and a higher concentration of those salts staying in the bloodstream. So, how does your body do that? How do the kidneys know how much of their job they have to do to maintain this water balance at the exact right amount, the salt balance at the exact right amount? Well, there is a hormone for that. There are sensors inside your bloodstream called baroreceptors that sense the pressure inside your bloodstream. And they send these signals back to the brain, specifically to the hypothalamus and the pituitary gland, that say, hey, the blood pressure is at this level. We might need to release a hormone called antidiuretic hormone to maintain the kidney's job. Let's be more specific. If you have a low blood pressure, the hypothalamus is going to sense that and send a signal to the pituitary gland to release more antidiuretic hormone. Antidiuretic hormone means that we want to reduce the amount of urine that is created, meaning that we're going to absorb more water inside the kidneys to reduce the amount of volume that's getting into the urine itself, making that blood pressure return to normal because we're now retaining more water. The exact opposite happens when we have a high blood pressure. The hypothalamus tells the pituitary gland to back off on the amount of ADH that it produces, which tells the kidney, hey, we don't really need to resorb any more water. Let it go in the urine, and the urine input, or excuse me, the urine output increases in volume, regulating our blood pressure at the same time. How awesome is that? The brilliant part of this actually is regulating how hydrated we are and how much water is available to all of our organs at exactly the same time. As in, this is the response that allows our body to maintain hydration and respond to dehydration or overhydration. As in, when you are dehydrated, that means that the kidneys are supposed to resorb more water because you aren't drinking enough. So therefore, the urine volume is going to decrease. You're going to pee less often, and that pee that you do generate is going to be darker and more concentrated. So the kidneys doing their job and keeping water inside your body is going to lead to colors like this amber or even like light brownish color here that show us, hey, the kidneys are keeping the water inside the body. There's not much left outside the body. At the same time, we can have this response for overhydration, meaning that when the ADH levels decrease because we have enough water in our bloodstream, the kidneys are going to resorb less of it, causing you to create more urine and therefore have more water in your urine, making your urine lighter and more dilute. It's kind of like this one right here. Your urine should be a amber straw color no matter what. If you are having clear urine that does not have any color to it, you are overhydrated. Please back off the water a little bit. This is just one thing that we can tell inside of our urine based on what's happening inside the body and what's happening inside the nephron specifically. So that nephron is going to be pretty important going forward with how much waste it's able to get rid of, or how much water it retains, or how much salt is found in it, and therefore how many uh, ions are available in your urine. The urine tells us a lot. We'll see that in a couple of activities here.